Hello dear students, welcome to my channel. ಇವತ್ತು ನೋಡಿ ಫಸ್ಟ್ ಕ್ವಾರ್ಟರ್ಲಿ ಟೆಸ್ಟ್ ಪೇಪರ್ ಆಗಸ್ಟ್ 2024. ಸೊ ಇದು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಆಲ್ಮೋಸ್ಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲ ಸಿಂಪಲ್ ಆಗಿದೆ. ಸೊ ಆದರೂ ಈ ಥರ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಸಾಲ್ವ್ ಮಾಡೋದ್ರಿಂದ ನೆಕ್ಸ್ಟ್ ಅಪ್ಕಮಿಂಗ್ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅದು ನಿಮಗೆ ಒಂದು ಐಡಿಯಾ ಸಿಗುತ್ತೆ. ಸೊ ಈಗ ನೋಡಿ ಕ್ವಶನ್ಸ್ ಫಸ್ಟ್ MCQ ಪಾರ್ಟ್ ಎಲ್ಲಿ MCQ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇದು ಫಸ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಈಗ ಫಸ್ಟ್ ಕ್ವಶನ್ ನಂಬರ್ question number 1, the charge on a body to which 6.25 into 10 power 18 electrons are added. Okay, so ಇದು ಸುಮಾರು ಜನ +1 ಕೂಲಮ್ ಅಂತ ಅನ್ಕೊಂತಾರೆ ನೋಡಿ. ಸೊ ಇಲ್ಲಿ 6.25 into 10 power 18 electrons ಏನಿದೆ, ಸೊ ಆಡೆಡ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಆಡ್ ಮಾಡಿದ್ರೆ ಸೊ ಬಾಡಿಗೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. ಸೊ ಬಾಡಿ ಗೆಟ್ಸ್ ನೆಗೆಟಿವ್ಲಿ ಚಾರ್ಜ್. ಓಕೆ, 6.25 into 10 power 18 electrons ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಸೊ ಆಗ ಬಾಡಿಗೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ +1 ಕೂಲಮ್ ಬರುತ್ತೆ. ಬಟ್ 6.25 into 10 power 18 electrons ಆಡ್ ಮಾಡಿದ್ರೆ ಸೊ ಬಾಡಿ ಗೆಟ್ಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ -1 ಕೂಲಮ್. ರೈಟ್ ಆನ್ಸರ್ -1 ಕೂಲಮ್. ಮತ್ತೆ SI ಯೂನಿಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ವಾಟ್ ಇಸ್ ದ SI ಯೂನಿಟ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್? ಸೊ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಈಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಚಾರ್ಜ್ ಅಂಡ್ ಡೈಪೋಲ್ ಲೆಂತ್. So charge is measured in terms of coulomb. 2 under dipole length is measured in terms of meter, coulomb meter. So the right answer is option C. So option C is the right answer, coulomb meter. The next question number 3, the potential at any point inside a hollow charged spherical conductor of radius is given, radius 0.2 meter, is 1 volt. The potential on the surface of the conductor. So actually electric potential within and on the surface is same. Andre electric potential surface mele eniruttho inside same irutte. So electric potential on the surface andre, so that is 1 volt. The right answer is option B. So next question number 4, the capacitance of a parallel plate capacitor is increased by. The capacity of parallel plate capacitor, capacity of parallel plate capacitor. So what is the formula? C is equal to epsilon naught epsilon or A by B. So ಇಲ್ಲಿ capacity increase ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ಇನ್ಕ್ರೀಸ್ ಅಂದ್ರೆ ಏರಿಯಾನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಸೊ ಏರಿಯಾ ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಸಪರೇಷನ್ ಬಿಟ್ವೀನ್ ದ ಪ್ಲೇಟ್ಸ್ ಡಿಕ್ರೀಸ್ ಮಾಡಬೇಕು, ಇಲ್ಲ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು. ಈಗ ನೋಡಿ ಆಪ್ಷನ್ಸ್, ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಏರಿಯಾ, ಸೊ ದಿಸ್ ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್. ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಇದು ರಾಂಗ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಸಪರೇಷನ್ ಏನಿದೆ ಅದು ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಕೆಪಾಸಿಟಿ ಆಕ್ಚುಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ರೈಟ್. ಸೊ ನೆಕ್ಸ್ಟ್ ಡಿಕ್ರೀಸಿಂಗ್ ದ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್, ಇದು ಕೂಡ ರಾಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಕೆಪಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ರೈಟ್. ಸೊ ಇದಕ್ಕೆ ರೈಟ್ ಆನ್ಸರ್ ಬಂದು ಆಪ್ಷನ್ ಎ. ಸೊ SI ಯೂನಿಟ್ ಆಫ್ ಮೊಬಿಲಿಟಿ ಆಫ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. So mobility is the ratio of drift velocity of current carrier to the applied electric field. So what is the SI unit? So drift velocity unit meter per second, and electric field unit volt per meter. So this is meter square per volt second. So SI unit meter square per volt second. So ಇಲ್ಲಿ meter square per volt second ನೋಡಿ, option C. Option C is the right answer. So next question number 6, on increasing the temperature of a conductor, its resistance increases because. So as the temperature increases, relaxation time actually decreases. So the right answer option A. Second, as the temperature increases, drift velocity. So drift velocity ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ decrease ಆಗುತ್ತೆ. Okay. So formula VD is equal to E tau by m ಅಂತ ಬರುತ್ತೆ. So as the temperature increases, So drift velocity of electrons in a conductor decreases. So drift velocity ಯಾವಾಗ decrease ಆಗುತ್ತೆ, so relaxation time ಕೂಡ ಏನಾಗುತ್ತೆ, decrease ಆಗುತ್ತೆ. The right answer is option A. The radius of circular path described by a charged particle entering a magnetic field. Entering a magnetic field normally. Okay, the radius of circular path described by a charged particle entering a magnetic field normally. So actually charged particle describes circular path. So andre mv square divided by r is equal to qvb. So the vv cancel ಆಗುತ್ತೆ. So radius r is equal to mv divided by qb. So the right answer r is equal to mv divided by qb. Option D is the right answer. Only 7 MCQ ಇದೆ. So the first part is the second part ಅಲ್ಲಿ fill in the blanks, 3 questions ಕೊಟ್ಟಿದ್ದಾರೆ. So SI unit of electric flux. The electric flux is product of electric field and area. So Newton per coulomb meter square. Newton meter square per coulomb. So ಅಂದ್ರೆ 8th question ಗೆ Newton meter square per coulomb ಬರುತ್ತೆ. So next, the significance of Kirchhoff's junction rule is a law of conservation of charge. Okay, so this is based on law of conservation of charge. So 9th one get right answer, charge. Next, a charged particle enters an electric field in the direction of the field, the nature of path traced by it. So when a charged particle enters uniform magnetic field parallel to the direction of magnetic field andre, so angle theta is equal to 0 barutte. The force acting on charged particle 0. So nature of trajectory straight line barutte. Okay, because it does not experience any force, so straight over there, so straight line. So the right answer is straight line. Next, part B. State and explain Coulomb's law of electrostatics. State and explain Coulomb's law of electrostatics ಅಂತ ಹೇಳಿದ್ದಾರೆ. So ಇದಕ್ಕೆ first ನೀವು statement ಬರೆಯಬೇಕು. The magnitude of force of attraction or repulsion between 2 point charges at rest is directly proportional to product of magnitude of 2 point charges and inversely proportional to square of distance between them. So statement ಗೆ 1 mark ಇರುತ್ತೆ. ಆಮೇಲೆ light explanation. So force is directly proportional to Q1 into Q2 and inversely proportional to square of the distance. Remove the proportionality, we will get the proportionality constant. So in SI system, for free space, that value is 1 divided by 4 pi epsilon naught. So Q1, Q2 divided by R square. So it's to baratada. So we complete 2 marks here. So next, question number 12. But if 200 joule of work is done in moving 2 microcoulomb of charge from point A to point B, find the potential difference. Potential difference between A and B. So work done in moving charge from A to B. So in brother VB minus VA into the moving charge. So here we want the potential difference. So VB minus VA under WAB, actually that is given 200 joule divided by Q. Q is 2 into 10 power minus 6. So 2 ones, so this is hundreds. So 10 power 2 into 10 power another 6, and the potential difference 10 power 8 volt. Potential difference 10 power 8 ohm. Next, question number 13. Give any 2 limitations of Ohm's law. So Ohm's law is applicable only for metallic conductors. Okay, Ohm's law is applicable only for metallic conductors. First point. But the Ohm's law holds good only if all physical conditions, that means temperature, pressure, strain, that should be kept constant. So ಇದೆಲ್ಲ ಲಿಮಿಟೇಷನ್ಸ್ ಆಫ್ ಓಮ್ಸ್ ಲಾ ಆಗುತ್ತೆ. ಓಮ್ಸ್ ಲಾ ಏನಿದೆ ಅದು ಕಂಡಕ್ಟರ್ಸ್ಗೆ ಮಾತ್ರ ನಾವು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಸೊ ಓಮ್ಸ್ ಲಾ ಇಸ್ ನಾಟ್ ಅಪ್ಲಿಕೇಬಲ್ ಫಾರ್ ಡಯೋಡ್, ಟ್ರಯೋಡ್, ಟ್ರಾನ್ಸಿಸ್ಟರ್, ಥರ್ಮಿಸ್ಟರ್, ಪಿ ಎನ್ ಜಂಕ್ಷನ್, ವ್ಯಾಕ್ಯೂಮ್ ಟ್ಯೂಬ್, ಡಿಸ್ಚಾರ್ಜ್ ಟ್ಯೂಬ್ಸ್, ಯಾವುದಕ್ಕೂ ನಾವು ಓಮ್ಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಸೊ ಓಮ್ಸ್ ಲಾ ಇಸ್ ಅಪ್ಲಿಕೇಬಲ್ ಓನ್ಲಿ ಫಾರ್ ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ಸ್, not applicable for diode, triode, transistor, thermistor, PN junction, vacuum tube, discharge tubes. And Ohm's law holds good only if all physical conditions remain same. So 2 points we mentioned madre. So nimge 2 mark barate. So mention the expression for the Lorentz force and explain the terms. So Lorentz force mathematical expression. Lorentz force under the force acting on a charged particle. Charged particle is moving in a region where both electric and magnetic fields are present. So that is called Lorentz force. The formula F is equal to F vector is equal to Q E vector plus Q of V vector cross B vector. So this is a mathematical expression. So terms explain ಮಾಡಬೇಕಾಗಿದೆ, ಯಾಕಂದ್ರೆ explain the terms ಅಂತ ಕೇಳಿದ್ದಾರೆ ನೋಡಿ. Q means charge of a particle, E means electric field, V is the velocity of charged particle. The next question number 15. Write any two properties of electric field lines. Now part C. So this is very important. So 3 mark questions. Scoring ಚೆನ್ನಾಗಾಗುತ್ತೆ. 3 mark 2 mark ಅಲ್ಲಿ. So write any 3 properties of electric field lines and the electric field lines, the number of properties ಇದೆ. So electric field lines are directed away from positive point charge. Electric field lines directed towards negative point charge. Electric field line starts from positive point charge and terminate on negative point charge. A tangent drawn at any point on the electric field line which gives the direction of electric field at that point. Electric field lines are closer, which means electric field strength is stronger. Electric field lines are spread out, which means electric field strength is weaker. So electric field lines will strike parallel, equidistant in uniform electric field. Electric field lines never intersect with each other, never be closed loops. Electric field lines contract lengthwise, which represents force of attraction between two equal and opposite charges. Electric field lines will exert lateral pressure, which represents the force of repulsion between two like point charges. Number of properties ಇದೆ. So 3 properties ನೀವು mention ಮಾಡಿದ್ರೆ so ನಿಮಗೆ 3 mark ಬರುತ್ತೆ. So this is a very important repeated 3 mark question. So maximum repeated question idu. And obtain the relation between electric field and electric potential. So this is also very simple. Question number 16 note kodi. Let us consider here a positive point charge. ನಾನು choose ಮಾಡ್ತಾ ಇದ್ದೇನೆ. So derivation is very simple. Let us consider here the 2 observation points. 2 observation points. So one is point A and another one is point B. And then consider here potential at point A as V, and potential at point B, that is V plus dV. Potential at point B is V, potential at point A is V plus dV. ಯಾಕಂದ್ರೆ observation point charge particle ಗೆ near ಇದೆ ಅಂದ್ರೆ so potential maximum ಇರುತ್ತೆ, right? So ಈಗ ನೋಡಿ ಪಾಯಿಂಟ್ ಬಿ ಹತ್ರ ನಾವು ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಇಟ್ರೆ ಡ್ಯೂ ಟು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಏನಾಗುತ್ತೆ, ರಿಪಲ್ ಆಗುತ್ತೆ. ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ಎಫ್ ವ್ಯಾಕ್ಟರ್ is equal to q into e vector. Now this charge is moving from B to A. So against electric force through a displacement dr. So dr vector. So here distance from B to A is dr. So what is the angle between F vector and dr vector? That is 180 degree. So first now work done in moving charge Q naught from B to A ಅದು calculate ಮಾಡಬೇಕು. So according to scheme of valuation ಏನು ಬರೀಬೇಕು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಅಷ್ಟು ಮಾತ್ರ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಈಗ ನೋಡಿ small amount of work done, small amount of work done in moving, small amount of work done in moving the charge plus q naught from b to a, from b to a. So that is w ba is equal to in ಬರುತ್ತೆ ಅಂದ್ರೆ WBA, and a small amount of work done in moving the charge from B to A. That is just W on the choose man. W is equal to W under meaning work done, small amount of work done in moving Q naught from B to A. So that is equal to force vector dot displacement vector. So FDR cos 180 ಬರುತ್ತೆ. So cos 180 is -1 ಅಂದ್ರೆ minus FDR. So F is Q naught E. F is nothing but Q naught E. So minus Q naught E into dr. So W by Q naught is equal to minus E into dr. So by using the definition of potential difference between A and B. So that is W is equal to potential difference between A and B andre VB minus VA is equal to W by Q naught. So this is the definition. So VB andre that is V. So in the potential difference between A and B, higher potential minus lower potential ಮಾಡಬೇಕು ನಾವು. So higher potential ಬಂದು ಇಲ್ಲಿ VA ಇದೆ. So ಅದಕ್ಕೆ VA minus VB ಮಾಡಬೇಕು. So VA minus VB is equal to W by Q naught. So VA is V plus DV. So V plus DV minus V is equal to W by Q naught. So VV cancels here. But you got two equations, just compare ಮಾಡಿ ನಮಗೆ ಆನ್ಸರ್ ಸಿಗುತ್ತೆ. Call this is equation number 1, call this is equation number 2. Comparing the equations 1 and 2. So then we will get minus E dr is equal to dV. So E is equal to minus dV by dr. So negative sign indicates potential decreases in the direction of electric field. Potential decreases in direction of electric field. So ಇದು ಅಷ್ಟೇ ತುಂಬಾ important repeated 3 mark derivation. So electric potentially maximum repeat ಆಗಿರೋ question ಇದು. Relation connecting between electric field and electric potential. Next question number 17. Derive the expression for drift velocity of free electrons in a conductor when electric field is applied across it. So ಈಗ expression for drift velocity ನಾವು ಮಾಡಬೇಕು. So ಈಗ first here let us consider a cylindrical conductor. ಒಂದು cylindrical conductor ತಗೋಣ. Cylindrical conductor, so that is connected to a battery and through a plug. Cylindrical conductor is connected to a battery through a plug. This is a cylindrical conductor. This is connected to battery through a plug. This positive terminal. This one is negative terminal. So when a conductor is connected to battery, so the free electrons so get drifted in a direction opposite to the direction of applied electric field. So that is the drift velocity direction and electric field. So this is the direction of electric field. So this is plus and this one is minus. So first, what is the acceleration of the electron inside the conductor under the influence of electric field. ಅದನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು by using uh, kinematic equation. First kinematic equation use ಮಾಡೋಣ. So V vector is equal to U vector plus A vector into T. So ಇದನ್ನ ಅಪ್ಲೈ ಮಾಡಬೇಕು. So ಇಲ್ಲಿ ನೋಡಿ V vector becomes VD vector, and U vector, this term goes to 0 because electron drift ಆಗುತ್ತೆ, ಇನ್ನೊಂದು electron ಗೆ collide ಆಗಿ ಅದು stop ಆಗುತ್ತೆ. So ಅದಕ್ಕೆ starting from rest and the initial velocity is 0. So T is called the relaxation time, that is tau. So A vector, so V vector plus VD vector ಬರುತ್ತೆ. So VD vector is equal to A vector into tau. So A vector is equal to VD vector divided by tau. So the force acting on electron due to electric field. So F vector is equal to E into E vector. Actually minus E into E vector. Okay. So F vector, according to Newton's second law, F vector is equal to M into A vector. So F vector is equal to M. A vector is an unfinite margin, that is VD vector divided by tau. So call this is equation number 1 and call this is equation number 2. Okay, just simple, very simple derivation. Just see two equations compare ಮಾಡಿದ್ರೆ we will get the expression for drift velocity in terms of relaxation time. Okay. ಈಗ ಕಂಪೇರಿಂಗ್ equations 1 and 2, then ಏನು ಬರುತ್ತೆ ಅಂದ್ರೆ m into VD vector divided by tau is equal to minus E into E vector. So VD vector is equal to minus E vector tau divided by m. So this is the expression for drift velocity. So just really derive the expression for drift velocity of free electrons in a conductor when electric field is applied across it ಅಂತ ಹೇಳಿದ್ದಾರೆ. So ಇಷ್ಟು ನೀವು derive ಮಾಡಿದ್ರೆ ಸಾಕು. So VD vector is equal to minus E vector tau divided by m. So what is the significance of negative sign? ಇಲ್ಲಿ negative sign significance ಏನು ಅಂದ್ರೆ, so the direction of drift velocity is opposite to the direction of applied electric field. Direction of drift velocity is so that is opposite to the direction of electric field. It is a very important 3-mark derivation. The next question number 18 ನೋಡ್ಕೊಳ್ಳಿ. Obtain the relation between current density, electrical conductivity and electric field. So obtain the relation connecting between current density, electrical conductivity. Where J vector is equal to sigma into E vector. So ಇದನ್ನ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. This is question number 18. So again, let us consider a cylindrical conductor of length L, and that is having uniform cross-sectional area A. So V with the potential difference across the ends of the conductor. So the magnitude of electric field. So firstly now magnitude of electric field across the ends of the conductor. But even E is equal to actually minus dV by dr. So magnitude of electric field across the ends of the conductor. So in E is equal to V by L. So V is equal to E into L. V is equal to E into L. So call this is equation number 1 according to Ohm's law. So according to Ohm's law, V is equal to IR. So V is equal to IR is rho L by A. So and call this is equation number 2. Now compare these two equations 1 and 2 from equations 1 and 2 from equations 1 and 2. So I rho L by A is equal to EL. So LHS sides same ಇದೆ, RHS sides equate ಮಾಡಿದೀನಿ ನಾನು. So L ಏನಾಗುತ್ತೆ, LL cancels here. So I by A is equal to E by rho. So I by A is current density. J is equal to 1 by rho is sigma. So J is equal to sigma E. ಬೇಕಾದ್ರೆ ನೀವು sense I by A andre that is current density. So current flowing through any cross section of a conductor per unit area is called current density. Okay, and 1 by rho andre sigma. So in vector notations, J vector is equal to sigma into E vector anta now mention ಮಾಡ್ತೇವೆ, right? So next ನೋಡಿ part D ಅಲ್ಲಿ so very important expected derivations ಕೇಳಿದ್ದಾರೆ. So derive an expression for electric field due to an electric dipole at a point on the axial line. The point on the axial line. ಸ್ವಲ್ಪ ಫಾಸ್ಟ್ ಆಗಿ ನಾನು ಮಾಡ್ತೀನಿ, ಆಲ್ರೆಡಿ ನಿಮ್ಗೆ ಗೊತ್ತಿರುತ್ತೆ. ಸೊ ನೋಡ್ಕೊಂಡ್ರೆ ಕ್ಲಿಯರ್ ಆಗಿ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ಬಿಡುತ್ತೆ. ಈಗ ನೋಡಿ, ಫಸ್ಟ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಹಿಯರ್ electric dipole. Electric dipole andre that is having pair of equal and opposite charges. Electric dipole having pair of equal and opposite charges separated by a small vector distance. It is directed from negative charge to positive charge. So this is the direction of dipole axis, the direction of dipole axis and direction of dipole moment. So both are same, that is from negative charge to positive charge. So this is the axial line. A line passing through the dipole axis is called axial line, and this is the observation point. So now a test charge plus Q naught is placed at the observation point P due to minus Q at A. Due to minus Q at A. So plus Q naught ಏನಾಗುತ್ತೆ due to minus Q at A. So plus Q naught at P. So that will experiences repulsive force. So this arrow mark is very very important. So ಸುಮಾರು ಜನ ಮಿಸ್ಟೇಕ್ ಮಾಡೋದು ಇಲ್ಲೇ. ಸೊ ಇದನ್ನ ಕೇರ್ಫುಲ್ ಆಗಿ ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಟ್ ಪಿ ಡ್ಯೂ ಟು ಪ್ಲಸ್ ಕ್ಯೂ ಅಂದ್ರೆ ಪ್ಲಸ್ ಕ್ಯೂ ನಾಟ್ ಏನಾಗುತ್ತೆ, ರಿಪಲ್ ಆಗುತ್ತೆ. ಸೊ ಡ್ಯೂ ಟು ಮೈನಸ್ ಕ್ಯೂ, ಸೊ ಏನಾಗುತ್ತೆ, ಪ್ಲಸ್ ಕ್ಯೂ ನಾಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ attractive force. So this is EA vector and this is EB vector, and distance from P to B distance ಮತ್ತೆ A to, this is center of the electric dipole, center in the observation point distance R bರುತ್ತೆ. So this is R. The distance from P to B is R minus A, and distance from P to A, so P to A, so this is R plus A. So derivation is very simple. First let us consider P is equal to Q into 2A. So this is called electric dipole moment. Now first ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ electric intensity at P. So due to plus Q at B, ಏನು ಬರುತ್ತೆ. So EB vector. So EB vector is equal to 1 divided by 4 pi epsilon naught. So Q divided by distance is R minus A. So this is R minus A whole square, and this is along which direction under EB vector along OP ಬರುತ್ತೆ, because due to plus Q not ripple ಆಗ್ತದೆ ನೋಡಿ, ಡೈರೆಕ್ಷನ್ ನೋಡ್ಕೊಳ್ಳಿ, along OP. So ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಸೈನ್ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ along OP ಬರಬೇಕು. So that is scheme of valuation. So the magnitude of EB vector is EB is equal to 1 divided by 4 pi epsilon naught Q divided by R minus A whole square, and call this is equation number 1. And electric intensity, so next point P due to minus Q, electric intensity at point P due to minus Q at A, so that is in birthday, right? That is EA vector is equal to 1 by 4 pi naught Q divided by R plus A whole square. Distance from observation point to A, distance R plus A. The formula is equal to 1 by 4 pi epsilon q by R square. So R and the distance from observation point to point charge R plus A, that R plus A whole square. Vector sign the direction mentioned ಮಾಡಬೇಕು. So along which direction EA vector along PO. So this is along PO. The magnitude of EA vector is EA. EA is equal to 1 divided by 4 pi epsilon naught. So Q divided by R plus A whole square, and call this is equation number 2. Now compare these two equations from 1 and 2. So here EB is more than EA. So EB is more than EA. So then the resultant electric field magnitude of resultant electric intensity at point P. So EA is equal to so EB minus EA, higher electric field minus smaller electric field. So A ಅಂದ್ರೆ electric intensity at a point in the axial line ನೋಡಿ ಈಗ two equations observe ಮಾಡಿ EB and EA. So ಅದರಲ್ಲಿ Q divided by 4 pi epsilon naught common ಆಗುತ್ತೆ. So remaining 1 divided by ಏನು ಬರುತ್ತೆ R minus A whole square minus 1 divided by R plus A whole square. So Q divided by 4 pi epsilon naught. The LCM is R minus A whole square into R plus A whole square. Simplify ಮಾಡಿದ್ರೆ R square plus so R minus A whole square cancel ಆಗುತ್ತೆ. R plus A whole square ಉಳಿಯುತ್ತೆ. R square plus A square plus 2RA minus ಇಲ್ಲಿ R plus A whole square cancel ಆಗುತ್ತೆ. R minus A whole square ಉಳಿಯುತ್ತೆ. ಅಂದ್ರೆ minus R square minus A square minus of minus plus 2RA ಬರುತ್ತೆ. So R square A square cancel. Q divided by 4 pi epsilon ಇದು 2 into 2RA divided by R plus A into R minus A, R square minus A square, ಮತ್ತೆ R plus A into R minus A ಬರುತ್ತೆ, R square minus A square. So R square minus A square whole square. Q into 2A is P. So 1 divided by 4 pi epsilon naught in brother 2PR divided by R square plus R square minus A square whole square ಬರುತ್ತೆ. So this is electric intensity at a point on the axial line. So for short electric dipole, and if R is much greater compared to A, so A square is negligible. So electric intensity at a point in the axial line is 1 divided by 4 pi epsilon naught. So 2P divided by 2PR divided by R power 4 ಆಗುತ್ತೆ. So A square is negligible. So R power 4, R divided by R power 4 ಅಂದ್ರೆ. So this is R cube. 1R cancel ಆಗುತ್ತೆ. So ಇಷ್ಟು ಬರೆದರೆ ಸಾಕು, ಕಂಪ್ಲೀಟ್ ನಿಮಗೆ 5 ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಡಿರೈವೇಶನ್ ನೋಡ್ಕೊಳ್ಳಿ. ಕ್ವಶನ್ ನಂಬರ್ 20. Define electric potential at a point in an electric field. So definition ಗೆ 1 ಮಾರ್ಕ್ ಇರುತ್ತೆ. Derive an expression for electric potential at a point due to isolated positive point charge. Second chapter ಅಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಡಿರೈವೇಶನ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಆರಾಮಾಗಿ ಮಾಡ್ಬೋದು. ನೋಡ್ಕೊಳ್ಳಿ ಡಿರೈವೇಶನ್ ಯಾವ ರೀತಿ ಮಾಡೋದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ ನಾನು. ಸೊ ದಿಸ್ ಇಸ್ ಕ್ವಶನ್ ನಂಬರ್ ಎಷ್ಟಿದೆ? ಕ್ವಶನ್ ನಂಬರ್ 20. So what is the definition of electric potential? Andre electric potential at a point in electric field. So what is the meaning of electric potential? Electric potential at a point in electric field. So this is measured by amount of work done in bringing a unit positive test charge. Amount of work done in bringing a unit positive test charge from where to where? Infinity to that point against electric force of the field. So that is the meaning of electric potential at a point in electric field. So first statement ಬರಬೇಕು, ಅದಕ್ಕೆ 1 ಮಾರ್ಕ್ ಇರುತ್ತೆ. So electric potential at a point in electric field is measured by amount of work done in bringing unit positive test charge from infinity to point P against electric force of the field. Now consider here two observation points. One is A and another one is B. Now a test charge plus Q naught is placed at the observation point A. Due to plus Q at O, plus Q naught at A will experiences repulsive force, that is F vector. So now consider here distance from A to O, distance from A to O. So this is X. X is the distance from A to O. So Q naught na ಏನು ಮಾಡಬೇಕು move ಮಾಡಬೇಕು from point A to point B through a displacement dx. So that is dx vector. So the angle between F vector and dx vector here, that is 180 degree. So first, according to Coulomb's inverse square law, so first ಇಲ್ಲಿ ನಾವು Coulomb's inverse square law use ಮಾಡಬೇಕು. So first step in the derivation, very simple derivation ಇದು ಕೂಡ according to Coulomb's inverse square law. According to Coulomb's inverse square law. The force acting on plus Q naught due to force acting on plus Q naught due to plus Q and Baratandra F is equal to Coulomb's inverse square law use ಮಾಡ್ತಾರದು. F is equal to 1 divided by 4 pi epsilon naught. Two charges, on the Q and on the Q naught divided by separation x ಇದೆ ಅದಕ್ಕೆ x square ಬರುತ್ತೆ. So ಈಗ small amount of work done, small amount of work done work done in moving the charge plus Q naught from where to where A to B. So against electric force W is equal to F vector dot dx vector, F vector dot dx vector. So in Bharata F dx cos 180, cos 180 is minus 1. So F is 1 divided by 4 pi epsilon naught Q naught divided by Q naught divided by x square, cos 180 is minus 1. So this is dw. So but we want total work done in moving the charge plus Q naught from where to where, infinity to point P. Infinity andre x is equal to infinity ಬರುತ್ತೆ, P andre so x is equal to r. Let us consider here the distance from O to P is r. So ಈಗ ಇದಕ್ಕೆ ಇಂಟಿಗ್ರೇಷನ್ ಅಪ್ಲೈ ಮಾಡಿ, ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ dw is equal to ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಏನು ಬರುತ್ತೆ ಮೈನಸ್, ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಟರ್ಮ್ಸ್ ಹೊರಗಡೆ ಹಾಕೋಣ. ಸೊ ಮೈನಸ್ q naught divided by 4 pi epsilon naught is constant, take it as outside. So integration of 1 by x square into dx. So x limits varies from infinity to r. Integration of dw is w. So q naught shift ಮಾಡಿ, so minus q divided by ಏನು ಬರುತ್ತೆ 4 pi epsilon naught. So integration of 1 by x square ಅಂದ್ರೆ that is minus 1 by x. So limits apply ಮಾಡಬೇಕು, x is equal to infinity to x is equal to r. ನೋಡಿ ಇಲ್ಲಿ ಮೈನಸ್ ಮೈನಸ್ ಏನಾಗುತ್ತೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತೆ. ಸೊ w by q naught that is equal to 1 divided by 4 pi epsilon naught. First upper limit apply ಮಾಡಿ 1 by r. So adamele lower limit apply ಮಾಡಿ 1 by infinity. So 1 by infinity goes to 0. So by the definition of electric potential at a point, so V andre W by Q naught. So finally we will get the expression. So V is equal to 1 by 4 pi epsilon naught. V is equal to 1 divided by 4 pi epsilon naught Q. So Q divided by R. Okay, W by Q naught, this is Q divided by 4 pi epsilon naught. Upper limit apply ಮಾಡಿದೀನಿ 1 by R minus 1 by infinity. 1 by infinity goes to 0. So 1 by 4 pi epsilon naught Q by R. So this is the expression for electric potential at a point due to isolated positive point charge. So this is very important. Repeated derivation. ಇದೆಲ್ಲ repeated derivations. ನೋಡಿ next question. Obtain the condition for balance of Wheatstone's network using Kirchhoff's rules. So Kirchhoff's rules use ಮಾಡಿ ನಾವು ಈಗ balancing condition find out ಮಾಡಬೇಕು. Actually Wheatstone's network ಅಂದ್ರೆ that is arrangement of 4 resistances in the form of quadrilateral. So use it for measuring one unknown resistance. Use it for measuring one unknown resistance in terms of three known resistances. ಸೊ ಇಲ್ಲಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್ ಕರೆಕ್ಟ್ ಆಗಿ ಡ್ರಾ ಮಾಡಬೇಕು. ಜೊತೆಗೆ ಸೊ ಆರೋ ಮಾರ್ಕ್ಸ್ ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ಇಂಡಿಕೇಟ್ ಮಾಡಬೇಕು. ಈಗ ನೋಡಿ, so this is arrangement of four resistances in the form of quadrilateral. So use it for measuring one unknown resistance in terms of three known resistances. ಅಲ್ಲಿ four resistances ಇರುತ್ತೆ. So ಅದನ್ನ ನಾವು ಅರೇಂಜ್ ಮಾಡಬೇಕು. So that is in the form of quadrilateral. So use it for measuring one unknown resistance in terms of three known resistances. So let us consider four resistances. One is R and another one is S. This is P and this one is Q. The four resistances are arranged in the form of quadrilateral, that is A, B, C, D and the choose manner. So one pair of opposite corners ಏನಿದೆ, one pair of opposite corners A and C. So ಅದಕ್ಕೆ ನಾವು ಬ್ಯಾಟ್ರಿ ಅಂಡ್ ಪ್ಲಗ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ಇನ್ನೊಂದು ಪೇರ್ ಆಫ್ ಆಪೋಸಿಟ್ ಕಾರ್ನರ್ಸ್ ಏನಿದೆ, ಸೊ ಅದಕ್ಕೆ ನಾವು ಒಂದು ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಗ್ಯಾಲ್ವನೋಮೀಟರ್ ಇಸ್ connected between another pair of opposite corners. Okay, right. ಈಗ ನೋಡಿ ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಬೇಕು. ಸೊ ದಟ್ ಈಸ್ ಆಕ್ಚುಲಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಸುಮಾರು ಜನ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತಾರೆ. ಕರೆಂಟ್ ಇಸ್ ಆಲ್ವೇಸ್ ಫ್ಲೋನ್ ಫ್ರಮ್ the positive terminal of the battery. At this junction, current is split into two parts. One is current flowing through R and another one is current flowing through P. And at this junction again, current is split into two parts. One is current flowing through the galvanometer and another one is current flowing through S. So ಮತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ ಸ್ಪ್ಲಿಟ್ ಆಗಿದೆ, ಬಟ್ ಇಲ್ಲಿ ಕರೆಂಟ್ ಕಂಬೈನ್ಡ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ, ಕರೆಂಟ್ ಆಕ್ಚುಲಿ I2 is entering, IG is entering ಅಂದ್ರೆ, so this current should be leaving. So that is I4. I4 is equal to I2 plus and ಬರುತ್ತೆ IG. Okay. So ಈಗ ನೋಡಿ ಲೂಪ್ಸ್ ಅಲ್ಲಿ ನಾವು ಇಂಡಿಕೇಶನ್ಸ್ ಮಾಡ್ಕೋಬೇಕು. So let us consider here the clockwise. ಇದು ಕೂಡ ನಾನು clockwise ಚೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸ್ವಲ್ಪ ಹೇಳೋದನ್ನ ಕೇರ್ಫುಲ್ ಆಗಿ ಕೇಳಿಸ್ಕೊಂಡ್ಬಿಡಿ. ಫಸ್ಟ್ ಹಿಯರ್ ಅಪ್ಲೈ ಕಿರ್ಚಾಫ್ಸ್ ಜಂಕ್ಷನ್ ರೂಲ್, ಕಿರ್ಚಾಫ್ಸ್ ಕರೆಂಟ್ ಲಾ at junction B. The sum of currents leaving is equal to sum of currents entering. I3 is the leaving, sum of current leaving is only I3 is equal to sum of currents is leaving is I3 and IG. So andre I3 plus IG is equal to entering current is only I1. The sum of currents leaving is equal to sum of currents entering. So I3 is equal to I1 minus IG, and call this is equation number 1. And then apply Kirchhoff's same current law at junction B. So sum of currents leaving is I4 is equal to sum of currents entering, that is I2 plus IG, and call this is equation number 2. And then apply Kirchhoff's voltage law to the loop. Apply Kirchhoff's voltage law to the loop, that is ABDA. ನೋಡಿ, ಇಂಡಿಕೇಶನ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದ್ರೆ ಪಾಸಿಟಿವ್, ಇಲ್ಲಾಂದ್ರೆ ಆಪೋಸಿಟ್ ಇದೆ ಅಂದ್ರೆ ಅದು ನೆಗೆಟಿವ್ ಆಗುತ್ತೆ. ಸರ್ ಇಂಡಿಕೇಶನ್ ಕ್ಲಾಕ್ ವೈಸ್ ಇದೆ, A to B ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಇಸ್ ಕ್ಲಾಕ್ ವೈಸ್, ಅದು ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಪ್ಲಸ್ I1 ಆರ್ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇಂಡಿಕೇಶನ್ ಕ್ಲಾಕ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಕ್ಲಾಕ್ ಪ್ಲಸ್ ಬರುತ್ತೆ, ಪ್ಲಸ್ IGG. ಇಂಡಿಕೇಶನ್ ಕ್ಲಾಕ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ನೋಡಿ ಆಂಟಿ ಕ್ಲಾಕ್ ಇದೆ, ಅದಕ್ಕೆ ಮೈನಸ್ I2 P is equal to 0. There is no EMF, ಅದಕ್ಕೆ is equal to 0. So call this is equation number 3. And then apply Kirchhoff's voltage law to the loop, that is BCDB loop ಗೆ Kirchhoff's voltage law ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಸೊ ಈಗ ನೋಡಿ B to C ಇಂಡಿಕೇಶನ್ ಕ್ಲಾಕ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಕೂಡ ಕ್ಲಾಕ್ ಇದೆ, ಸೊ ಅದು ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ಅಂದ್ರೆ ಪ್ಲಸ್ I3S. ನೆಕ್ಸ್ಟ್ ಇಂಡಿಕೇಶನ್ ಕ್ಲಾಕ್ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ನೋಡಿ ಆಂಟಿ ಕ್ಲಾಕ್ ಇದೆ ಫ್ರಮ್ C to D, ಸೊ ಅದಕ್ಕೆ ಇದು ನೆಗೆಟಿವ್ ತಗೋಬೇಕು ಅಂದ್ರೆ ಮೈನಸ್ I4Q. So next indication clock, ಇಲ್ಲಿ current flowing anti clock ಇದೆ ಅಂದ್ರೆ minus IGG is equal to 0. So I3 is nothing but I1 minus IG, I4 is I2 plus IG. So I3 ಅಂದ್ರೆ I1 minus IG, ನೋಡಿ ಇಲ್ಲಿ find out ಮಾಡಿದ್ದೇನೆ, I1 minus I1 minus IG into S minus I4 is I2 plus IG into Q minus IG G is equal to 0. So ಈಗ ನೋಡಿ ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಈಗ if S, P and Q are adjusted ಎಲ್ಲಿವರೆಗೂ ಅಡ್ಜಸ್ಟ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ until the current flowing through the galvanometer is 0. SPQ are adjusted until current flowing through the galvanometer is 0. So then equation this one 3, equation 3 becomes equation number 4 ಅಂತ choose ಮಾಡಿ. equation 3 ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ I1 or ನೋಡಿ ಈ ಟರ್ಮ್ 0 ಆಗುತ್ತೆ, minus I2P is equal to 0 ಅಂದ್ರೆ I1 or is equal to I2P, and then equation 4 becomes, ಈಗ ನೋಡಿ IG term goes to 0, I1S ಬರುತ್ತೆ. So I1S minus ಇಲ್ಲಿ IG term 0 ಆಗುತ್ತೆ. So minus I2Q is equal to 0, andre I1S is equal to I2Q. So call this is equation number 5. So call this is equation number 6. So 5 divided by 6 madre. So we will get I1 or divided by I1S is equal to I2P divided by I2Q, I1 cancel. So finally we will get R by S is equal to P by Q. So this is a balancing condition of Wheatstone's network. So this is a very, very, very important repeated 5 mark. So maximum. The next question number 22 note, derive the expression for magnetic field at a point on the axis of circular current loop. It is the most expected repeated derivation. Expression for magnetic field at a point on the axis of circular current loop. So this is question number 22. Almost all questions ನಾನು in detail explain ಮಾಡ್ತಾ ಇದ್ದೇನೆ. So ಇದನ್ನ ನೀವು ಕೇಳಿಸ್ಕೊಂಡ್ರೆ ನಿಮಗೆ maximum use ಆಗುತ್ತೆ. So question number 22, magnetic field at a point on the axis of current loop. So ಇಲ್ಲಿ diagram, ಪ್ರತಿಯೊಂದು derivation ಅಲ್ಲೂ diagram draw ಮಾಡೋದು physics ಅಲ್ಲಿ very important. So diagram ನೋಡ್ಕೊಂಡು ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ಮಾಡಿದಿರಾ ಇಲ್ವಾ ಅದು ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ. ಈಗ ನೋಡ್ಕೊಳ್ಳಿ, ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ನಾನು ಚೂಸ್ ಮಾಡಿರೋದು ಈಗ ಒಂದು ಕರೆಂಟ್ ಲೂಪ್, ಆಕ್ಚುಲಿ ಆಫ್ ಆಫ್ ದ ಟರ್ನ್ ಏನಿದೆ, ಸೊ ಆಫ್ ಆಫ್ ದ ಟರ್ನ್, ಸೊ ದಟ್ ಈಸ್ directed away from the plane of the screen ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಸೊ ರಿಮೈನಿಂಗ್ ಆಫ್ ಟರ್ನ್ is directed into the plane of the screen. ಈಗ ನೋಡಿ ಡಾಟೆಡ್ ಲೈನ್ ಏನಿದೆ, ಸೊ ಇಂಡಿಕೇಟ್ಸ್ ಟರ್ನ್ is into the plane of the screen ಆಗುತ್ತೆ, ಮತ್ತೆ thick line is directed away from the plane of the screen ಆಗುತ್ತೆ, ಮತ್ತೆ plane of the loop plane of the screen ಗೆ exactly perpendicular ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ನಾವು ಫಸ್ಟ್ diametrically opposite elements ಈಗ choose ಮಾಡಬೇಕು. Let us consider here two elements, one is AB and another one is CD. So these are diametrically opposite. Midpoint of ABE ಅಂತ choose ಮಾಡ್ತಾ ಇದ್ದೇನೆ, midpoint of CDF ಅಂತ choose ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಸೊ ಈಗ ನಾವು ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ BL vector draw ಮಾಡಬೇಕು. BL vector, okay, BL vector draw ಮಾಡಬೇಕು ಅಂದ್ರೆ tangent draw ಮಾಡಬೇಕು. ಆಕ್ಚುಲಿ ಇದು ನಾರ್ಮಲಿ outwards ಇದೆ, so this is normally inverse ಇರುತ್ತೆ. Now consider the axis. Okay, this is the axis of the loop, okay. ಈಗ ನಾವು ಪೊಸಿಷನ್ ವೆಕ್ಟರ್ ಚೂಸ್ ಮಾಡೋಣ. the position vector. Okay, this is the position vector or vector. This is or vector. This is or vector. This one is or vector. So this is observation point P. Observation point P. So you have magnetic field at point P due to current in AB. So current direction first mark ಮಾಡಬೇಕು. This is the direction of current. Current flowing in anti-clockwise direction. So current flow ಆದರೆ ಆಗ ಇಲ್ಲಿ magnetic field produce ಆಗುತ್ತೆ. The magnetic field is always perpendicular to the plane containing two rotational vectors. Magnetic field B vector ಏನಿದೆ, so that is perpendicular to the plane containing two rotational vectors. The angle between P vector and dB vector 90 degree irutte, ಮತ್ತೆ angle between again dB vector and R vector, that is 90 degree. So nodi, this is radius. So this is the radius of the loop. Radius of the loop. But the center in the observation point zero distance na x and the choose ಮಾಡ್ತೇನೆ. So different colors use ಮಾಡ್ತಾ ಇದ್ದೇನೆ, so ನಿಮಗೆ clear ಆಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. Okay, ನೋಡಿ ಈ distance, this is x, the x ಬರುತ್ತೆ, right? And this is the radius, ಇಲ್ಲಿರೋದು radius of the loop. So this is the radius, okay, and this is x. And let us consider this angle as phi, and this angle is also phi. So ego dB vector does not align x and y direction. So dB vector ಏನಿದೆ ಅದು x direction ಅಲ್ಲೂ ಇಲ್ಲ, so y direction ಅಲ್ಲೂ ಇಲ್ಲ. If a vector does not lie in x and y direction, so that vector should be split into two components. So two components ಆಗಿ dB vector ನ ನಾವು ಏನು ಮಾಡಬೇಕು, ಸ್ಪ್ಲಿಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಇಲ್ಲಿ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ರೆಕ್ಟಾಂಗಲ್ ತಗೊಂಡ್ಬಿಟ್ರೆ ಸ್ಪ್ಲಿಟ್ ಮಾಡೋದಕ್ಕೆ ನಿಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. This is angle phi. Notice this angle is 90 minus phi. This angle is phi, and this angle is also phi. So this is perpendicular hypotenuse base component under. So in barate dB cos phi barate, and this component is dB sin phi. And this is perpendicular hypotenuse base component is dB cos phi, and this one is dB sin phi. So this is along px direction, and dB cos phi along py. dB cos phi, so that is along py dash. So diagram ಈ ತರ ಇರಬೇಕು, ತುಂಬಾ ಕ್ಲಿಯರ್ ಆಗಿ ನಾನು ಹೇಳಿದ್ದೇನೆ. ಸೊ ಈ ರೀತಿ ಡ್ರಾ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಕಂಪ್ಲೀಟ್ ಮ್ಯಾಥ್ಸ್ ಬಂದೇ ಬರುತ್ತೆ, ಅಂದ್ರೆ ಕಂಪ್ಲೀಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇಲ್ಲಿ ಅಪ್ಲೈ ಆಗಿದೆ. So angle between ನೋಡಿ ಇಲ್ಲಿ dB, actually this is dl vector and this is the dl vector. So angle between dl vector and r vector 90 degree ಇರುತ್ತೆ. So ಇದು normally outwards, so ಇದು normally inwards. ಇಲ್ಲಿ ಕೂಡ angle between dl vector and r vector, so this angle is equal to 90 degree. So let us consider this point as O. ಈಗ ನೋಡ್ಕೊಳ್ಳಿ derivation in the triangle OEP. ನಾವು Pythagoras theorem first apply ಮಾಡಬೇಕು. Small r square is equal to capital R square plus n ಬರುತ್ತೆ, x square ಬರುತ್ತೆ. So small r is equal to r square plus x square whole power 1 by 2. And in the triangle OEP, sin phi is equal to perpendicular divided by hypotenuse, capital R divided by small r. And ಈಗ ನಾವು Biot-Savart's law apply ಮಾಡಬೇಕು. According to Biot-Savart's law, so magnetic field at point P due to current in the element AB, so that is dB is equal to dB vector is equal to mu naught divided by 4 pi I dl divided by distance from observation point to midpoint, that is small r, and there is small r square ಬರುತ್ತೆ. And sin theta is the angle between dl vector and r vector, so that is 90 sin 90 ಬರುತ್ತೆ. So ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಸೈನ್ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಅಲಾಂಗ್ PM ಅಂತ ಚೂಸ್ ಮಾಡೋಣ. PM ಅಂತ ಚೂಸ್ ಮಾಡೋಣ. ಸೊ ದಿಸ್ ಇಸ್ ಅಲಾಂಗ್ PM. So magnetic field at point P due to current in AB, and dB is equal to mu naught divided by 4 pi. So ideal divided by R square, and call this is equation number 1. And similarly, same as it is, magnetic field again Biot-Savart's law apply ಮಾಡಬೇಕು. Magnetic field at point P due to so current in the element CD. So that is dB vector is equal to mu naught divided by 4 pi ideal divided by R square. Again in the sine 90, and this is along the direction PM. So magnitude of dB vector is dB is equal to mu naught divided by 4 pi ideal divided by R square, and call this is equation number 2. So here dB vector along PM. So this is splits into two rectangular components. One is dB cos phi, and this is along py direction. Another one is dB sin phi along px direction. And dB vector, so along Pn is also splits into two components here. So one is dB cos phi along py dash, and another one is dB sin phi. So dB sin phi, so along px direction. ಈಗ ನೋಡಿ components ಇಲ್ಲಿ dB cos phi along py ಮತ್ತೆ dB cos phi along py dash. ಸೊ ಎರಡು ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ equal and opposite ಇದ್ರೆ ಏನಾಗುತ್ತೆ, components cancel ಆಗ್ಬಿಡುತ್ತೆ. Okay, the components or get cancelled with each other. And finally ಈಗ ನಾವು ಮಾಡಬೇಕಾದ್ರೆ resultant. ಈಗ ನೋಡಿ magnetic field the magnetic field at P due to current in AB and CD. ಈಗ ಇವೆರಡು ಕಾಂಪೊನೆಂಟ್ಸ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತಾ ಇದೆ. ಸೊ ಈ ಕಾಂಪೊನೆಂಟ್ಸ್ ನಾವು ಆಡ್ ಮಾಡಬೇಕು. ಸೊ magnetic field at point P due to current in AB and CD is dB sin phi plus dB sin phi ಬರುತ್ತೆ, and this is along the direction px, but one pair of opposite elements get dB sin phi plus dB sin phi. So ಅದರ number of diametrically opposite current elements ಇರುತ್ತೆ. So finally ನಾವು resultant ಮಾಡೋಣ. So resultant magnetic field at point P, so due to current in the entire loop ಅಂದ್ರೆ so B is equal to integration of dB sin phi. So B is equal to integration of dB is mu naught divided by 4 pi ideal divided by R. So sin phi is capital R by small r. Capital R by small r. dB andre is mu naught by 4 pi ideal by R square. So constant terms take it as outside here, mu naught by 4 pi I R divided by R square into R cube. Integration of dr. So B is equal to mu naught divided by 4 pi I capital R divided by small r is R square plus x square power 1 by 2. So whole power 3. Integration of dl is L andre 2 pi R barate. So B is equal to mu naught divided by 4 pi I R divided by so R square plus x square power 3 by 2. L is 2 pi R. So B is equal to mu naught divided by 4 pi 2 pi I R square. So divided by R square plus x square power 3 by 2. So in vector form, B vector is equal to mu naught divided by 4 pi 2 pi I R square divided by R square plus x square power 3 by 2 I cap. So I cap andre, so that is along positive x direction. This is in vector form. So vector form ಬರೀಬೇಕಾದ್ರೆ ನೀವು vector sign ಯೂಸ್ ಮಾಡಿದೀವಿ ಅಂದ್ರೆ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಜೊತೆಗೆ ಸೊ ಇಲ್ಲಿ ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಇದೆ. ಓಕೆ, ದಿಸ್ ಇಸ್ I cap. Suppose a coil having n number of turns ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ 2 pi ni r square divided by r square plus x square power 3/2 ಅಂತ ಬರುತ್ತೆ. Coil having n number of turns ಇದೆ. Only one loop ಅಂದ್ರೆ just mu naught divided by 4 pi 2 pi I r square divided by r square plus x square power 3/2. That's all. Okay, so actually ನೀವು exam ಅಲ್ಲಿ ಅಟೆಂಡ್ ಮಾಡಬೇಕಾಗಿರೋ only 2 questions, but 2 questions ಇದರಲ್ಲಿ choice ಇದೆ and complete 4 questions ನಾನು discuss ಮಾಡಿದ್ದೀನಿ, right? But all 4 questions are very important, repeated derivation. Last numerical part ಅಲ್ಲಿ ನೋಡಿ 2 numericals ಇದೆ. So 2 numericals ಈಗ solve ಮಾಡ್ತೀನಿ. Simple numericals ಕೊಟ್ಟಿದ್ದಾರೆ. So in a parallel plate capacitor, with air between the plates, each plate has an area. Area is given here. 6 into 10 power minus 3 meters square. The distance between the plates, the separation between the plates, 3 millimeter. Capacitance find out ಮಾಡಬೇಕು. So potential difference 100 volt supply. If the capacitor is connected to 100 volt supply, what is the charge on the plate of the capacitor? Okay, ಇದು ಅಷ್ಟೇ direct question ಇದು. First part ಅಲ್ಲಿ ನೋಡಿ ನಾವು C is equal to epsilon naught A by D formula choose ಮಾಡಬೇಕು. C is equal to epsilon naught A by D. That is the formula. First step, C is equal to epsilon naught A by D. This is question number 23 solution. Epsilon naught under 8.854 into 10 power minus 12, and area is 6 into 10 power minus 3, whole divided by separation is 3 into 10 power minus 3, 10 power minus 3 minus 3 cancel agada, 1s are 2s are. So 8.854 into 2 ಮಾಡಬೇಕು. So 8.854 into 2, 17.708 ಬರುತ್ತೆ. 17.708. So answer is 17.708 into 10 power minus 12 farad. And second part ಅಲ್ಲಿ ನೋಡಿ charge ಕೇಳಿದ್ದಾರೆ. ಎಷ್ಟು simple question ಇದು. Q is equal to CV. C is 17.708 into 10 power minus 12 into 100, 10 power 2. So 17.708 into 10 power minus 12, 2 minus 10 ಆಗುತ್ತೆ. So 1.7708 into 10 power minus 9, ಅಂದರೆ 1.77 ಏನಾಗುತ್ತೆ ನ್ಯಾನೋಕೂಲಮ್. So this is a charge. The capacity 17.708 10 power minus 12 farad. So charge is ಬೇಕಾದ್ರೆ ನೀವು ಇಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಮಾಡ್ಬೋದು. 17.708 10 power minus 10 farad. So 1.7 ಮಾಡ್ಕೊಂಡ್ರೆ 10 power 1 ಆಗುತ್ತೆ. 1 minus 10, so that is minus 9. So ಅದು ನ್ಯಾನೋಕೂಲಮ್ ಆಗುತ್ತೆ, right? So that's all. ನೋಡಿ ಎಷ್ಟು ಸಿಂಪಲ್. This is 5 mark numerical. ತುಂಬಾ ಈಸಿ ಇದೆ. ಸೊ ಆರಾಮಾಗಿ ಮಾಡ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ನ್ಯೂಮರಿಕಲ್ ನೋಡ್ಕೊಳ್ಳಿ. 2 cells of EMF 2 volt, ಇದನ್ನ E1 ಅಂತ choose ಮಾಡೋಣ, and another one is E2, so that is 4 volt, and internal resistance, this is R1 and this is R2, 2 ohm respectively, are connected in parallel. So as to send the current in the same direction through an external resistance is 20 ohm. So as to send the current in the same direction, andre cells must be connected in parallel. Andre positive terminals are connected to one common point, negative terminals are connected to another common point. So now the cells are connected in parallel. So this is the external resistance. So this is current drawn from E1, and this is current drawn from E2. So I1, I2. So both are in the same direction. So this is the main current I. So and external resistance is given, that is 20 ohm. So ಈಗ ನೋಡಿ formula formula is I is equal to EP divided by R plus RP. So ಈ formula use ಮಾಡಬೇಕು, but EP ನಾವು calculate ಮಾಡಬೇಕು. ಅದಕ್ಕೆ formula E1 R2 plus E2 R1 divided by R1 plus R2 ಬರುತ್ತೆ. So E1 R2, so E1 is 2, E1 is 2, R2 is 2, 2 into 2 ಏನಾಗುತ್ತೆ 4 plus E2 R1 4 into 1 4 divided by R1 plus R2. So that is 1 plus 2, that is 3. ಅಂದ್ರೆ EP ನಮಗೆ effective EMF ಬಂದು 8/3 ವೋಲ್ಟ್ ಬರುತ್ತೆ. And effective internal resistance formula R1 into R2 divided by R1 plus R2 ಅಂದ್ರೆ 1 into 2 divided by 1 plus 2 ಅಂದ್ರೆ 2/3 ohm ಬರುತ್ತೆ. And finally I is equal to EP is 8/3 divided by 1 plus RP is 2/3. So 8/3 divided by the LCM is 3. 3 plus 2 is 5. So 3 cancel ಆಗುತ್ತೆ. So 8/5. So 8/5 what ampere. But ಅಲ್ಲಿ ಕೇಳಿರೋದು potential difference across 20 ohm. So this is current flowing through 20 ohm. So finally third step ಅಲ್ಲಿ ನಾವು potential difference ಮಾಡಬೇಕು. Formula IR. So V is equal to I is 8/5 into R is 20. Okay. So in the external resistance ಬಂದು 20 ohm ಕೊಟ್ಟಿದ್ದಾರೆ. I'm sorry. So external resistance is 20. This is capital R. So formula is I is equal to EP is 8/3, RP is 2/3, and capital R ಬಂದು that is 20. 21. 20 plus 2/3. So 8/3. So LCM is ಏನಾಗುತ್ತೆ? LCM is 3. The 60 plus 2. 62. So 3 ಏನಾಗುತ್ತೆ? Cancel ಆಗುತ್ತೆ. So 8/62 ಬರುತ್ತೆ. 8/62. So this is the current, and we want potential difference across 20 ohm. And V is equal to I into R. And V is equal to 8/62 into capital R is 20. So ಇದನ್ನ simplify ಮಾಡಬೇಕು. 3s are 1s are. So 80/31. So 80 divided by 31 2.58. So 2.58 volt. So this is the potential difference across 20. ಅದಕ್ಕೆ ನ್ಯೂಮರಿಕಲ್ ಸಾಲ್ವ್ ಮಾಡಿದಾದ್ಮೇಲೆ ಸ್ವಲ್ಪ ಒಂಚೂರು ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡಿ. ಸೊ ಏನಾದರೂ ಮೈನರ್ ಕರೆಕ್ಷನ್ಸ್ ಇದ್ರೆ ಮತ್ತೆ ಅದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಓಕೆ ಓಕೆ, ಥ್ಯಾಂಕ್ಸ್ ಫಾರ್ ವಾಚಿಂಗ್ ದಿಸ್ ವಿಡಿಯೋ. ಆಲ್ಮೋಸ್ಟ್ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೇನೆ. ಕಂಪ್ಲೀಟ್ ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಏನೇನು ಕ್ವಶನ್ಸ್ ಇದೆ ಎಲ್ಲ ಪಾರ್ಟ್ಸ್ ಅಲ್ಲಿ MCQ ನೋಡಿ, ಇನ್ಕ್ಲೂಡಿಂಗ್ ಚಾಯ್ಸ್. ಆಕ್ಚುಲಿ ಇದರಲ್ಲಿ ಒನ್ ಕ್ವಶನ್ ಅಟೆಂಡ್ ಮಾಡಬೇಕು, ಟು 50% ಆಲ್ಮೋಸ್ಟ್ ಚಾಯ್ಸ್ ಇದೆ. ಬಟ್ ಆದರೂ ಎಲ್ಲ ಕ್ವಶನ್ಸ್ ಈಗ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. ಓಕೆ, ಫಸ್ಟ್ ಕ್ವಾರ್ಟರ್ಲಿ ಟೆಸ್ಟ್ August 2024. ಸೊ ಈ ಥರ ಕ್ವಶನ್ ಪೇಪರ್ಸ್ ಕಂಪ್ಲೀಟ್ ಸಾಲ್ವ್ ಮಾಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಅಪ್ಕಮಿಂಗ್ ಎಕ್ಸಾಮ್ಸ್ಗೆ ನಿಮಗೆ ತುಂಬ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ರೈಟ್.